Hello, everyone. Welcome to Clay Loves Logic, where on this channel I solve logic-based Sudoku puzzles I find interesting. Today on the channel, we're going to look at the puzzle Killer X 2 by EPH. As always, I'll put the link to this puzzle in the video's description so you can try it out if you'd like, but with that in mind, let's look at the rules. Looks like a fun one today. So, standard Sudoku rules apply. You have to have the digits 1 to 9 in every 3x3 box in every row and in every column. Digits may not repeat along the marked diagonal. That's going to be this. And that is going to be that. Digits in cages cannot repeat and must sum to the value in the corner of the cages. And there's a couple things I can tell you. Those are the rules. Let's solve the puzzle. 17 cage. Two digits. Has to be 8 and 9. 15 cage. In 5, just has to be 1, 2, 3, 4, 5. 16, 1, 2, 3, 4, 6. 17, 1, 2, 3, 4, 7. Does it always have to be that way? 1, 2, 3 is 6, 5 is 11, 6, 1, 2, yeah, 1, 2, 3, 5, 6. 1, 2, 3, 5, 6 is an option. Okay, but if we think about this, and we look at this central box, I mean, this has to have the digits 1 to 9 in it, doesn't it? Surely it does. I mean, those are the rules of Sudoku, and this does have standard Sudoku rules. So where do you put a 9? Well, there's never a world where you could fit it in the 15, the 16, or the 17. Can you even fit it in the 18? If you minimize everything else, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's still 10. 1, 2, 3, 4 is still 10. So this is always a 9. And then let's just work backwards. And if you minimize that's the point of this intro, isn't it? And that's really interesting. If you minimize all of these digits, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, you still always have to have an 8 in this central box. And if you have to have an 8 in the central box, it just has to be in the 18 cage, doesn't it? It's just going to be there because we can't put it in any other cage. Just like we have to put the 7 here. And none of these are 7. We have to put the 6 here, so none of these are 6. We have to put the 5 there, so none of these are 5. Such that this will have a 5, this will have a 6, this will have a 7, this will have an 8. And going from there, these 10 cages are doing a lot of good for us, aren't they? Because what do we know about a 10 cage in 2 digits? We have to have a low digit, 1, 2, 3, or 4. We have to have a high digit, 6, 7, 8, or 9, because we can't have double 5s. So there's going to be a low digit here and a high digit. I don't know the order of them, low, high, whatever. What I do know is there will be a low digit and there will be a high digit. So if this is a low digit, 1, 2, 3, or 4. This is a low digit, 1, 2, 3, or 4. This is a low digit, 1, 2, 3, or 4. And this is a low digit, 1, 2, 3, or 4. Then how could these be anything other than 5 and 8? And they just can't. That's a 5. That is an 8. This has lost its ability to be 8. This has lost its ability to be 5. Then these have to be 3, 4s, 6s, and 7s. Because they can't be 1, 9, and they can't be 2, 8, because we have those in the middle. And that is going to give us a 1, 2 pair. And I'm sure that trick is just going to work here as well, won't it? A 10 and an 11 cage. And now the question is, where does a 5 go in this row? And we can see it can't go in this central box. Can't go in a 10 cage. It can't repeat in a 15 cage. And it doesn't have room in an 18 cage. So this is 5, 6. So actually, this is not 6. So actually, this is 6. And then this 10 cage, right? What is this? It has to have a low digit and it has to have a high digit. And we already see 3. So that does the same thing, doesn't it? Where now this is a 7. And I don't know how you got all these extra digits. 1, 2, 3, or 4. So what is this? It's not 6, 7, or 9. So it's 2, 8. Oh, and then none of these are 2. Isn't that right? And if none of these are 2, then this is a 2. That's going to remove all of these ability to be a 2. That's going to remove these abilities to be a 2. This is not a 2 anymore because of this 2, 8 pair. And this is not a 2 because of this 2. There's another 2 we get. Lucky boy. We have a 1, 3, 4 triple. And okay. Interesting. Very interesting, actually. So what now? What do we know now? Where does an okay, so 8. I mean, there's an 8 down here somewhere, sure, certainly. What else is there? Do we know? What about 5s and 6s? This is a 5, 6 pair now, isn't it? Because there's a 5, 6 here. So this is a 7, 9 pair. And then by that math or logic, this is a 7, 9 pair. And this is going to be a 1, 3, 4, 8 quadruple. Wow, okay. Let's look now at the 6 cage we have. So that's from 1, 2, 4, and 5, not 2, not 4. And I want to now think that I want to kind of start using the same trick where 1, 2, and 3 are all low digits. And we need one more low digit here. And that means this can't be a low digit because then we'd have 5 low digits. You know, if this is 1, this is 2, this is 3, we have a 4 over here. What could this ever be? This is a 5. 5 is going to give us 1. That's going to give us a 3, 4 pair, which is going to not only make this a 1, 8 cage, but it's also going to give us a 1 here, isn't it? Because now where does a 1 go in the 18 cage? There. And now, where does a 1 go in this cage? Here, here. Where does a 1 go in this cage? Here, here. Oh, in this cage, where does a 1 go? Only here. So we have a 3, 4 pair, a 1, 3, 4 triple. And the same logic applies to this 11 cage, where we have 3 low digits, and we'll have the 4th low digit here. So this is from 5, 6, 8, or 9. And a 5, 6, 8, or 9 would make it 5, 6. 8 would make it 3. 9 would make it 2. Well, it's never 3 because we have a 3, 4 pair. 3 is removed, which means 8 is removed. So this is 2, 5, or 6. And I just think that's fine. There's always a 5 somewhere up here. A 1, 3, 4 triple. What's this then? 5, 6, 9, and 8. But this is never an 8. But this could be an 8, I guess. Yeah, that could be an 8. Okay. What about this 10 cage now? We have an awfully lot of low digits here, but I don't know if I can say which is which. A 9. Well, that's actually really powerful that this 1 is here, right? Because how do you make 9 in 3 digits? Well, your options are anything that involves a 1 is off the table. So you can only have it as 2, 3, 4. There's a 2 on this diagonal. So this is not a 2. Okay. So where's a 2 go in here? Well, it's always in one of the boxes. What a stupid question. What a silly question. What about 1 now? Because it can't go on there. So a 1 is in one of 2 places. And that is going to put a 1 in one of 2 places here. And then where do we put a 1? Nowhere there. Nowhere here. Oh, and actually, look. Again, we can't forget that there's this sort of there's a stranglehold on low digits here, right? None of these can be low because we have 3 low digits here and a low digit there. So in fact, we never have a 1 in any of those positions. And a 1 can't be on the diagonal. So there's a 1 in the 13 cage, which is interesting. So the 13 cage now has to sum to 12. And if we look at our 8s and 9s, this 17 cage here tells us that neither of these are 8 or 9. So, oh, and a 9 is never on the diagonal. And can a 9 be in this 13 cage now? 9 and 1 is 10. So maybe. I wonder if we can do any better on these 3 4s. Let's do my favorite activity in the whole world. It should surprise nobody at this point. And let us color some digits with all these lovely 3 4 pairs we have. And then my question is, where does a blue digit go in this box? A better question I'm going to ask you is, where does a blue digit go in this cage? We have to have a blue digit in this cage. It can't be that. This is the blue digit. So it's not a 1. And we get a 1. Don't we? We get a 2. Where does a... Okay, let's do the same trick. Where does a pink digit go in this cage? Again, only there. So we get a digit, don't we? We get another... Well, this is a 1. That's powerful. Oh, and then this is a 2. Wow. Oh, that's really interesting. Okay, yeah. Oh, I like that. What do we need down here? 1, 2, 3, 4, 5. We need 7, 8, 9. No restrictions, I don't think. Okay, well, let's think now. Where do we put a pink digit? We need a pink digit. Well, we need lots of pink digits, but we can't have a pink digit on the line there. We can't have a pink digit there or there or there or there via all sorts of trickery. So a pink digit is only in one of 2 places. And then what is that telling us? Well, look at what it's telling us is that blue and pink are always in these 4 places. Can they exist together? Can we have blue and pink in the same spot? Actually, wait 1 second. We can do one better. We can say this is the pink world, and this is the blue world. One of these is blue, blue plus something else. Could pink be up? Could blue be up here, actually? I think it could. Well, I don't know yet. Let's keep thinking. Where do you put a 9? All sorts of places. Somewhere up here. Does a 9 go in a 13 cage? Well, 9 actually, not all sorts of places, because a 9 can't go in any of those places because 9's on the thing. I have to remember that. Can a 9 go on a 13 cage? If you have a 9 on a 13 cage, then you need 1 and 3, don't you? Yeah. I think that's fine. I don't know. Okay, let's keep thinking. What are these collection of digits? 5, 6, 8, 9. Oh, well, one of these is always 5. Yeah. So this is just 6, 8. Oops. 6, 8, 9. Because there's a 5 in this box already. So one of these is 5. And then what are these? 2, 5, 6, 7, 2, 5, 6, 7. This is not a 2. This is not a 2. 2 is in one of two places. What do we, sorry, so what do we know for sure? We know that a 5 is in one of two places. We know that a 2 is in one of two places. That's it so far. Okay. What about this 10 cage? Ah, well, look, the 10 cage has all the low digits except for blue. So this is going to be 3, 4, 6, 7 in some capacity. It's just the alternate of that. And that forces these to be blue and pink. But look at, we have one of the blue pink digits here. So we can only have one more on this line. But can we have both? A blue and a pink would give us 7, and we would need 6 more. And again, I think that's fine. I don't really see an issue with what would be stopping us from putting 6 there. Yeah, not sure. Okay. What else can I say? We need blue and pink somewhere up here, don't we? And we don't, oh, actually, there's a thought. We need the blue, we need a blue somewhere on this line. Well, all the blue available in box 9 is spoken for. One of those two. There's no blue on there. That can't be a blue. So in fact, certainly blue is in one of two positions. And then what can we say? What do we need? We need a pink somewhere on this line. Could very well be there. Okay. What's this digit? This digit can't be 1, 2, 3, 4. This digit is 5. This digit is 6. This digit is 7 or 8. Yeah, and what do we? Oh, we'll have this one pencil mark right there. That's silly. That must have been. I don't know when that showed up. Must have been a mistake. Anyways, what do we need here? 1, 2, 3, 4. We need 5, 6, 7, 8, 9. And no real rhyme or reason to help us figure it out. Um. Well, this is always going to be blue and pink alternating. One will be blue, one will be 2, or one will be pink and one will be 2. Doesn't matter. And that tells us, okay, that's interesting because now look, all the capacity for pink in these two rows is spoken for, which means pink is in one of two places here. I ask you, is that interesting? I answer you, no. No, unfortunately, I don't think it is. Um, well, one thing that is potentially interesting is This box always has a 9 here. This box always has a 9 in one of 3 spots. So one of these two is a 9. One of these two is a 9, which means one of these two is a 9. One of these two being a 9, one of these ones being a 9, means the 9 is over here. So 9 is not in the 13 cage. I don't know where it is. One thing. Look, that's not a 6. That's not a 6 because this is, there's a 6 on the diagonal. Oops. Oops, I don't mean to highlight all of that. That. Okay. So there's always a 6 somewhere over here. There's always a 2. There's always a 6. Okay. Now, what do we do with that information, please? What's the biggest digit we have in here? Because one thing to think about is there's no 8 down there. So, first of all, there is a 1 in this for sure. So knowing that there's a 1, can we also have blue and pink? And I'm going to say no, of course not, because blue and pink sum to 7. And 7 plus 1 does not sum to 13. So this color here, this is always one of them. This is always either blue or pink. So if this sums to 3, sorry. If the blue or pink digit we need is a 3, then we'd have 3, and we'd have 1, and we'd have to have 9. But we can't have 9. 9 is outside of the grid, which means this is 1, 4, and 8, doesn't it? Doesn't it mean that? And it does, of course. 8 plus 4, yeah, so this is a 3. So this is a 4, 3 in the corner of all things. This is not a 3, so this is not a 7. This is not a 4, nor is this. This is not a 4, which means this is not a 6. Now, what do we do with that information in our lives? The 8 is always here. The 8 is always here. Does that mean this is an 8? Yes. Yeah. You can't, there's always an 8 in here. There's always an 8 here or here. This is an 8. It's the only spot that's left. This is not an 8 anymore. And now, well, that's interesting. That is legitimately interesting. So, what do we do? This. Well, look, this could not be anything anymore. It sees both 3 and 4. This is never blue anymore, which means this is blue, which means it's not a 1, which means this is a 1. And we get another digit that gives us a 1 there. And we get to remove the coloring. This is now a 4-8 pair, and that is going to do worlds. None of those are 8. This is not 4, which means this is not 6. 4-8 pair. What is, oh, well, look at that. There's a 4 on the line now, isn't it? That's an 8. This is a 4, and an 8 is not deserving of color. And in fact, we don't know what colors these will have yet, but we know that this is a 3-4 pair now. He says as he pencil marks 2, 3. And that removes this ability to be blue. Yeah. Okay. This puzzle is finally yielding a little bit. Well, this is now, no, it's not. Never mind. Nonsense. What have we learned? 7, 8, 9, nothing yet. We have a naked single, don't we? What do you put an 8 in this box? Just there. This is not an 8 anymore. It's a 7, 9 pair. And that's interesting because there's always an 8 up here now. There's always an 8 here, which means one of these is an 8. So this is an 8, 9 pair. So this is going to be a 5, 6, 7 triple, isn't it? It is, of course. And then this is a 5, 6, 7 triple, isn't it? And then what are you? We have a 3, 4. We have a 9, a 6, and 8. What do we even? Well, first of all, we need a 1, don't we? We need a 1 somewhere on this line. It's not here. It's not down here. And Sudoku tells us it is not any of those places. This is a 1. And that doesn't. Oh, it does. It gives us an 8 and a 1 and a 9 and an 8 and a 7 and a 9 and did not really and terribly mean to click that, but I kind of did, but that's okay. 3, 4, what does that mean? This is not a 3 or a 4. It is a 6 or it is a 7, neither of which are blue. This is blue. So now that is not blue anymore. Blue's 4, isn't it? Blue's 4. Blue's 4. Oops, blue's 4. Yeah, blue's 4. Yeah. So pink is 3. Whoops. 3. So then this is a 3, 7 pair. A 3, 7 pair gives us a 9, doesn't it? Because this could only be 7 or 9. So 9 gives us 7. This is now a 6, 8 pair. This is going to be now 5 or 9. 5 or 9 removes this ability to be a 5. So this is only 2 or 6 for maths. But let's not slow down. What do we know about these diagonals? We need a 2, a 5, and a 7. Am I correct? 2, 5, and 7. Don't we? That is simply all we need. 2, 5, 7, and that will fill it. And it's unwavering so far. This is 5, 6, 7 with no yield. 5, 6, 5, 6, 7, 5, 6, 7, 9. 5, 6, 7, 9. All right. So then what now? And let us not slow down, for progress is ours. This is a 3, is it not? Of course it is. How could this be a 3? And this will be a 2 and a 3 and a 3 and a 7. And let's just remove. I want to keep the color on the 3s. I've earned it. That's not a 7 anymore. So this is a 7 or this is a 7. Great. So this is just, yeah, I mean, we're really chugging along. This is 2, 5, 6, 7, isn't it? 2, 5, 2, 5, 6, 7. And it's not a 5 or 7. So this is a 2, 6. And now we have, oh, how is this a 5? 2, 6, 8, 9. Yeah, that's just a missed pencil mark or an incomplete. That's a 2. That's an 8. That's a 2. That's a 6. That's a 6 via 5, 6, 7 pairs. That's a 5. That's a 5. That's a 6. That's a 6. This is a 2 via Sudoku. This is 7, which makes this a 5, which makes this a 7, which makes this a 9, 7, 5, 6, 5, 9. 7, 7, 2, 6, 5, 9, 9, 5, 7, 8, 9, 6, 8. 31 minutes, 43 seconds. 381 people have solved this puzzle in 329 days. I like this puzzle. That was a fun puzzle. EPH. Great job. I really enjoyed that. Thanks, everyone. I hope you enjoyed it, and I'll see you on the next one.